everyone, welcome to this Math 082 video. This is 4.6. I wanted to do 2 more problems on learning how to solve equations involving polynomials. So if we look at example 6, the first thing is we're always using the zero product property to solve. So we want to make sure we actually have 0 on one side, and in this case you can see that we do. So then we move on to the left-hand side of the equation where we see all our numbers and variables. And remember, the first thing we always do is we look for a GCF. Very important. So remember, you can pause this video if you want to and see if you can do the problem ahead of me. Or if you want to, you can just follow along. In this case, our GCF is 2. So we still have a trinomial inside the parentheses. So trinomials, if you recall, we use the AC method. So we need 2 numbers that multiply up to 5 and add up to 6. 5 is a prime number, which is kind of nice. That limits our options significantly. So we find out that 5 times 1 is 5, and 5 plus 1 is 6. So we get x plus 5 and x plus 1. Now this is where it gets kind of interesting. Just like the problem I did in the last video, you can see that there are 1, 2, 3 values that are being multiplied. So a lot of times I see students doing this. They'll write either 2 equals 0, x plus 5 equals 0, or x plus 1 equals 0. Well, this is clearly the solution x equals negative 5, and this is clearly the solution x equals negative 1. But my question is, where is the x in this equation? This doesn't have an x. In fact, it's just a number. And when is 2 ever equal to 0? Well, it's not. That's just silly. 2 is equal to 2, and 0 is equal to 0. They're 2 different numbers, and so that statement is never going to be true. So we only need to concern ourselves with solving or setting the terms equal to 0 that contain a variable. All right, let's do one more problem. So let's look at example 7. So when we first look at it, you might think, oh my gosh, this is so awesome. Somebody factored this for me. So I can just start going ahead and solving it. I can write x plus 2 equals negative 28. And then I can write x minus 1 equals negative 28. And you're so excited, and then you realize, wait a minute. Did I use the zero product property on a number that isn't 0? And we did. We can't do that. You can only use the zero product property on 0. That's it. So in fact, the way this problem is written, they've actually created more work for us, because what we're going to have to do is we have to get 0 over here. So what are we going to have to do? Well, we're going to have to add 28 to both sides. So we're going to have x plus 2 times the quantity x minus 1, all of that plus 28 equals 0. Now, I don't know about you, but what I see on the left-hand side looks nothing like any of the things that we've worked through at all in this chapter. So we're going to have to do even more work. What we're going to have to do, if you remember from chapter 3, is we're going to have to FOIL. So we have first, outer, inner, last. And then we still have the rest of the equation just kind of hanging out there for us. Okay? So as you can see, you can combine the middle terms. So we get x squared plus x minus 2 plus 28 equals 0. So hopefully now you can see that negative 2 and positive 28 are also like terms. So we're going to end up with a 26 here. And then we'll just go ahead and bring down everything else. Okay? So at this point, let's think about what we can do. Well, we're probably going to have to use the AC method. So the AC method says that we need 2 numbers that multiply up to 26 and add up to 1. So if we do this, then, well, we have 13 times 2, but obviously 13 plus 2 is equal to 15. We have 26 times 1, which is 26, okay? And that's pretty much it. So it doesn't look like this is going to be able to be factored, so we're just going to have to write that this is prime, okay? Now, in later chapters, we'll probably learn other methods. As I mentioned before, there's like the quadratic formula and stuff. But for right now, this does not have a solution, so we can just write prime and leave it that way.